Dear students, welcome in another video about gas tanker handling. Today we will discuss two items, namely the heat exchangers on board of a gas carrier and the glycol system. We'll start with the heat exchanger, and there are a lot of heat exchangers on board of a gas tanker, but we will discuss only the most important ones, namely cargo heater, cargo vaporizers, and air dryers. The purpose of a heat exchanger is, as the name says, exchange heat between two, most of the time, liquids. Exchange heat between liquids can be between water and the cargo, between cargo and steam, or things like that. We will see immediately a few applications. The first one is the cargo heater. We stipulated already, or we spoke already about the cargo heater when we discussed this problem when we discharge cargo from a type A tank towards a type C tank. Then we need to warm up the cargo without evaporating it. So this will happen when the cargo is under a certain pressure. If not, the cargo will evaporate. So that is not the goal of a cargo heater. We have other instruments, we have other equipment on board to evaporate the cargo. Here, it is only the goal to warm up liquid without evaporation. So, how does this work? Well, we have one circuit where seawater is entering the heater, passing alongside some tubes, and then leaving the heater. On the other hand, cold liquid, most of the time coming from the booster pump, that we will use in this event. So there's always the combination of booster pump and heater. When we use the booster pump, we also use the heater. So cold liquid sent from the booster pump inside these tubes of the cargo heater, following the whole circuit, and then leaving on the other side as a warmer liquid, and then sent ashore. This works very good since we have sufficient seawater available, a whole ocean if you want. So at a quite important flow, the seawater is passing. Although the efficiency of the instrument will depend on the seawater temperature. That is why we need to know the seawater temperature at the inlet, and we need to know the seawater temperature at the outlet, because what might happen, don't forget that we send here cargo with negative temperature. If we don't send, if the capacity of the seawater is insufficient, we might risk that by the end, when the seawater is leaving the heater, that the seawater gets frozen. That is the highest risk of this instrument. And when the seawater starts freezing around the tubes, these tubes will be broken, heater broken, and yes, your holidays will start a bit earlier as expected. It's a very expensive equipment, as you might imagine. So this sensor here, which registers the outlet temperature of the seawater, is a very important one and should not become below +5 degrees. If ever you fall asleep and this temperature achieves a +5 degrees Celsius, your cargo pump and your booster pump are stopped automatically. Not the seawater pump, of course. The seawater pump is kept running just to add some additional heat and to warm up the cargo remaining in the heater. So this is an automatic protection of your heater. the capacity of the heater is limited by the seawater temperature. The warmer the seawater is, the more capacity you can send into the tubes and you can warm up. The final temperature that you will send to the shore is then achieved by this bypass valve, because what will come out of your heater is well above 0 degrees. That means that you cannot send negative temperature towards the shore. Let's assume that the minimum temperature allowable for the cargo tanker shore is -5 degrees. Yeah, what is coming out here is always a +5 degrees or even warmer than that. Let's assume +10 degrees, because you are limited by this sensor here. The outlet of the seawater must be always above +5. You take a bit margin above that, because otherwise your system will trip the whole time. So let's say +7, +8, the outlet of the seawater temperature. Thus, the liquid coming out of the heater, the cargo liquid coming out of the heater, will also be at a temperature of something like +5, +6, +7. But if -5 is acceptable for the shore, you must open this bypass here a little bit and send some very cold liquid to mix with the warmer, that finally what you got at the manifold and what you send ashore is something like, for example, -5. So by the use of this bypass, you can increase the flow rate, the discharging rate is shown. But of course, you understand already that if you arrive in a port where the seawater temperature is only 10 or 12 degrees, there's not so much heat inside this seawater. You will spend a lot of time, and your discharging rate will be limited by this cargo heater, and you will stay another week or something like that before everything has been discharged. Very nice ships, gas tankers. You will see a lot of the world. This is a cargo heater. This is the heater where you have, let me see, this is the seawater inlet. Yep, it goes all the way to the seawater outlet on top there. This is the cargo inlet that goes completely to the aft and then comes back completely to the fore and the cargo outlet. This is the seawater heater from inside. So some people put here booster heater, and you understand why they put booster heater, although it has nothing to see with a booster. It's a simple cargo heater, but the booster because you use this heater always in combination with the booster, of course. So in this case, the cargo is flowing through the small tubes and the seawater is flowing around the tubes. Yeah? That is the exchange of heat. Therefore, you need a maximum contact surface, and that is achieved by the use of these small tubes. Here the schematic drawing, you have our cargo pump that pumps the liquid to the deck level. On the deck level, this discharge pressure is increased by the booster pump, and only when this discharge pressure has been increased, we will pass through the heater in order to increase the temperature. Then we will mix near the manifold, we will mix with colder liquid to achieve the required temperature at the manifold, possibly negative. So with a cargo heater, we can avoid low temperature embrittlement, damage to the steel of the shore tanks steel. Fitted with temperature control, pressure control, prevent freezing, yes. And normally we should be able to raise the temperature from -45 to -5, but that is depending on the seawater temperature. Vaporizers. Another heat exchanger on board, and as the name says, this is an equipment that is used to vaporize the cargo liquid. In case we need a lot of vapor, we use the vaporizer. what are situations where we need a lot of vapor? Well, that is in the preparation of the tanks, as we will see in chapter 6, when we start gassing up the tank, when we change the atmosphere in the tank by cargo vapors, then we need a lot of vapors. Well, then we will use the vaporizer. When we discharge at a high rate, and that the ambient natural evaporation of the cargo is insufficient to keep a positive pressure in the tank, then we will need a larger amount of vapors. We will start the vaporizer. Or when the cargo received from shore during loading is below its boiling point, that might create a negative pressure in the tank, then we urgently need a huge amount of vapors. We will start up the vaporizer. So there are a few situations where we will need a lot of vapor, and then the vaporizer is our help. Usually, most of the time, we have steam vaporizers. That means we will evaporate our cargo liquid by means of steam. It is possible with seawater also, but that is quite a risky business. Like we said with the heater, the freezing problem. Most of the vaporizers are horizontal, although vertical vaporizers exist also. So what we have here is cargo tank. With the cargo pump, we send liquid to this vertical vaporizer in this case. Liquid will be accumulated here at the bottom, and steam is passing to evaporate this liquid. At the top of the vaporizer, we got cargo vapor, and that is sent by the vapor line to the top of the tank. And so we keep a positive pressure in case we are discharging quickly, for example. So here you see that we are discharging also, that only part of that liquid is sent to the vaporizer. This is in fact the drawing of the vaporizer. So this is an horizontal vaporizer. We will find the horizontal vaporizer on the LNG carriers. So you have an LNG inlet and a LNG vapor outlet. You have a steam inlet and you have a steam outlet, and you have a condensate drain pot where the condensated water is accumulated. Okay, here again, there is a huge problem of freezing, and therefore this LNG inlet, as a kind of protection, will not open as long as the steam has not been opened. So first thing to do when you start up this heat exchanger, this vaporizer, is to open the steam inlet and the steam outlet. Yeah. Only then, when the vaporizer has been warmed up, you are able to open the LNG inlet. Liquid LNG is then sent through these small tubes. Here is only drawn one for simplicity, but there are, of course, a lot more. Liquid is then sent through these small tubes while steam is passing around the tubes. The steam will cool down, will condensate, and condensated water will accumulate here at the bottom of the vaporizer, and then accumulated in the drain pot, and this condensate is then sent back to the boilers. Finally, the LNG liquid will evaporate and gas will accumulate at the outlet of our vaporizer. Now, the temperature control is very difficult with this steam. So what we do is we open the steam completely, and we send the maximum capacity of the steam towards the vaporizer. That means that here at the outlet, if we don't pay attention, temperature can go above 100 degrees Celsius. That is not the goal. The goal is not to warm up our tank. The goal is to get cargo vapors at, let's say, for example, a temperature of 0 degrees. That would be nice. So instead of avoiding to sending too hot vapors to our tanks, we will first decrease the temperature here at the outlet of our vaporizer by spraying liquid droplets, liquid droplets inside this outlet. These droplets will evaporate. They will need heat to evaporate, and this heat is taken away from the vapor coming from the vaporizer. So the more we open this valve, the more liquid droplets we evaporate, and the colder will be the gas outlet. So it is with this valve that we will control the temperature outlet of the vaporizer. Very important that once you start up the vaporizer, that you immediately control the gas outlet temperature. And this is an example of an LNG vaporizer on board of an LNG vessel, horizontal one, as you see. Nothing else than a horizontal drum. There's nothing more to say about it. On board of an LNG tanker, we will have two vaporizers, as you see them here, a large one and a small one. This is called the cargo vaporizer, where we will evaporate cargo. This is called the forced vaporizer, where we will force liquid to evaporate. The principle of work is exactly the same. The only difference is the capacity. The cargo vaporizer has a high capacity. The forced vaporizer has only a small capacity. When do we use the cargo vaporizer? Yeah, when it's cargo related. When do we use the forced vaporizer? When we need additional vapors for propulsion purposes. That means when the boil-off only is not enough. Suppose you need to be urgently in the discharge port, you sail full speed, and a boil-off is not sufficient to maintain the speed, then you need additional vapors, and then you will create your vapors by the forcing vaporizer. So you will send liquid here inside the forced vaporizer, and the cargo vapors coming out are then sent to the boilers for propulsion purposes. And in that way, you have sufficient vapors available to maintain full speed. Then the air dryers. Air dryers are, as the word it says, are equipment that will dry air. When do you need dry air? Well, there are several applications where you need dry air, like, for example, in the hold space. Please keep in mind that related to the transport of ammonia, you will fill up the hold spaces with dry air and not with IG. Also, when you prepare your tanks, cargo tanks for the loading of ammonia, you will use dry air and not IG, since IG and ammonia are reacting with each other, and they will create a white powder which might contaminate your ammonia. So that is to avoid. That is the reason why, that's one of the reasons why you have air dryers on board. So the input of an air dryer is the normal ambient air. Output is air with a low dew point. This is more or less the schematic drawing. You have a compressor that is sending compressed air towards this drum, where you will cool down the ambient air. When you cool down the ambient air to its dew point, you will have condensation, and this condensation is then evacuated by another pump. When you have condensated the maximum of the humidity inside the air with possibly some smaller droplets inside are then sent through what we call a silica gel dryer. Silica gel is a substance that will eliminate the remaining droplets in the air, and that you can regenerate later on. So you can separate the humidity from the silica gel in the regeneration phase. So you have also always two silica gel dryers, one which is regenerating, another one which is used, so that you can still continue creating air, dry air. After the silica gel dryer, you bring the air to the normal ambient temperature. And then, of course, the dew point of the relative humidity of the air will further decrease. Depending on the cargo, you might need dry air or dry inert gas of up to dew points of minus 45 degrees Celsius for all cargo related use. Okay, to finish this video, this is a short one, we will have a last word about the Glicol system. Glicol system is an auxiliary system on board, closed system, that is continuously circulating. That is one of the first circuits that you will start whenever you start up this vessel or this tanker, gas tanker, after dry dock, for example. It is a system that will run 24 hours on 24, 7 on 7, the whole year round. It can be used for several purposes. Here are a few examples: as a cooling system for cargo compressor bearings, as a cargo compressor suction gas superheating in order to prevent condensation in the compressor, as a compressor loop oil heating to vaporize refrigerant which may contaminate the oil. So if you have in your oil, in your loop oil of the compressor, if that is contaminated with cargo, you keep it at, let's say, plus 40 degrees, then it is impossible that this cargo will remain in the oil because it will evaporate. And like that, you can separate oil from cargo. Cargo compressor cylinder heat or cool. You can also heat, or you can also cool it. In this case, you can cool the cylinder head with this Glicol when the compressor is running, of course. Cooling two-stage compressor intercoolers. Okay, you don't know what intercooler is, but that is for the next video. You will learn it there. Onboard LNG carriers to keep the cofferdams at a positive temperature. We didn't spoke about that yet, but the cofferdams, so the spaces in between two tanks, must be kept at a positive temperature. We mentioned that already. And the use of Glicol prevents freezing of the medium due to the very low working temperature it may be in contact with. So it's in fact an antifreeze that we circulate continuously through the various applications. So it gives this schematic drawing. Somewhere on deck we have a Glicol tank. So Glicol is an antifreeze. That Glicol is circulating continuously by this Glicol pump and sent to the different consumers. This can be a heater, for example, or this can be a cooler, or this can even be a cargo vaporizer. Instead of steam, you can use this Glicol system. The Glicol is normally kept at a temperature of about 40 degrees, not more, not less. Yeah, it's continuously circulating at 40 degrees. This is, of course, not very high temperature, so your cargo vaporizer in that case, or the vaporizer equipped with this Glicol heating, has a very limited capacity compared to vaporizers equipped with steam exchange. But okay, when your compressor is stopped, you can make sure that your loop oil is kept at plus 40 degrees, and so that condensation of the cargo is avoided. When your compressor is running, then you can use this 40 degrees as a cooling medium, because you will avoid that your compressor is achieving too high temperatures. So in both cases, it will work. And of course, this is only an example of some applications of some consumers of this glycol system. This glycol system can be connected to a lot more of applicants, but just for simplification, I only mentioned a few. Okay, that is it for this video. A smaller one, but that is because of 4.9 is quite a large one, and therefore I want to start a new video before I attack the boil off control. Thank you very much for your attention, and see you next time.